In this video we're going to look at how to solve trig equations. Now one of the diagrams you're going to come across in this topic is this diagram here, which is called our CAST diagram. CAST diagram is just an easy way of remembering the letters, C-A-S-T, although I'll give you another way as well. Now, where do these letters come from? You'll notice that A, S, T and C, three of these, S, T and C are your sine, tan and cos, and this one here stands for all. We also have a little a here which will stand for our acute angle, and what we've got here is 0 degrees and we are going anti-clockwise, 90, 180, 270, 360. Now I'll show you where these letters are placed where they are in the next slide. If you look at this diagram here, you'll see we have our three trig graphs all put together. So red is our graph of sine x, blue or purple is our graph of cos x, and this green one is our graph of tan x. So what we're going to do is break our CAST diagram. Remember, it starts at 0 degrees, 90, 180, 270, 360 anti-clockwise. So first of all, between 0 and 90 degrees, that is this section here. So I'll just very quickly highlight it. That's just in there. What you'll notice about the graphs there is all of them sit above the x-axis. So this CAST diagram will tell us where are these graphs positive. So between 0 and 90 degrees, all three graphs are above the axis and therefore positive. So we say between 0 and 90, A for all. All of the graphs are positive. What we can then do is highlight the section between 90 degrees and 180. Remember, if we're going 0, 90, 180, this is between 90 and 180 here. We can see the only graph that sits above the axis in this space is this red one, which is the graph of sine x. So we're going to put a capital S in the second quadrant. We're then going to highlight the third section, and in that you can see the only graph that is above the axis here is the green one, which is our tan graph. So between 180 and 270, or 180 and 270 here, the only graph which is positive is T for tan. And then lastly, we have between 270 and 360, or 270 and 360, only the cos graph is positive. So in this quadrant, we're going to put a C for cos. So that's where those letters come from in this CAST diagram, and what I'll probably do is I'll probably do a video later about how these other rules come into play, but at the moment what's important is we can remember it. Now we don't tend to draw it as one diagram like this, so I'm just very quickly going to sketch this out as two separate diagrams which will look like these. So first of all, we're going to have the one we'll draw out, which is our CAST diagram. All scholars take care, and with that we need to know the rules associated for each quadrant. These are our 1, 2, 3, 4 quadrants here, and the A quadrant is associated here as our first quadrant. That has the acute angle in it. Now the acute angle is the size of this angle here. What we have in this next quadrant is S for sine, and the rule associated with that is 180 minus the acute angle. Now the acute angle is exactly the same size as the acute angle here, so 180 take away this acute angle, and in the next quadrant, the tan quadrant, we have the rule 180 plus the acute angle. So we remember this is 180 degrees and we're adding on the size of this acute angle here to get to this, and in the final quadrant we have the rule 360 minus the acute angle. Remember, we're going around 0, 90, 180, 270, 360, so the size of the acute angle in here, 360 degrees, take away the size of that acute angle will give us this angle here. Now, we need to memorize both of these diagrams. Even though this is probably the one we're going to draw out each time, it's useful to obviously be able to draw that out as well, but you need to know the rule for each of these 4 quadrants by heart. Now, before we actually start solving trig equations, we need to understand how we use this CAST diagram or this quadrant diagram. What we're looking for here is we are looking at the value of either sine x, cos x or tan x. Now remember, these letters came about because these letters tell me where each graph is positive. So between 0 and 90, all graphs are above the axis. Between 90 and 180, only the sine graph is. Between 180 and 270, only the tan graph is above the axis, and between 270 and 360, only the cos graph is above the axis, and that's again where those letters came from. So if in a trig equation we end up with sine of x equal to a positive value, now that might be something like sine x equals a half, sine x equals a third, but a positive value, positive a half, positive a third. We know if sine x is equal to a positive, we know the sine graph is positive here, because all graphs are positive there. and we know the sine graph was positive here. So if sine is positive, we tick A for all and S for sine. And the same idea with the others. If cos is positive, well, where did we know the cos graph was positive? Well, all things are positive in the first quadrant, and cos is positive in the next quadrant. And if tan is positive, well, where is tan positive? Tan was positive in the first quadrant because all graphs are, so tick A for all, and it's positive in that third quadrant there where the T is. So basically, if the sine x, cos x, or tan x is equal to a positive number, we tick A for all things positive, and S for the matching letter. Sine is positive here, cos is positive at C, tan is positive at T. Now, if I tick those for when sine is positive, then that means that sine will be negative here and here. On this one, if cos is positive here and here, then cos is negative here and here. And if tan is positive there and there, then tan must have been negative here and here. So basically, if it is sine x equals a negative number, cos x equals a negative number, or tan x equals a negative number, we tick the opposite two than the two we would tick if it was positive. So again, sine x is negative, we know it's positive here and here, so therefore it must be negative here and here, the opposite two. If we know cos x is negative, we'll think cos x is positive here and here, so therefore it must be negative here and here. And again, if tan x is negative, well, we know tan is positive here and here, so therefore it must be negative in the other two, here and here. Now, on the next slide, what I'm going to do is I'm going to ask you to draw out a few cast diagrams and tick the correct quadrants based on what sine x, cos x, or tan x is equal to. So here's 6 questions for you to pause the video, copy out the questions and the cast diagrams and see if you can tick the correct quadrants. Then just play when you're ready. Before you start, just a quick idea. When we're talking about positive or negative, obviously that's positive 3/4, that is negative 2/3. So in the first one, just to get you started, sine x is equal to a positive 3/4, and therefore sine is positive here and here, all things positive and sine positive. Pause the video, do the other 5, and then press play when you're ready to go over them. Okay, so we'll quickly run through these. First of all, let's have a look at this first one. Cos of x is equal to negative 2/3, so cos is positive at all in cos, so A and C, so therefore it must be negative in the other two, sine and tan. So a good way to do it is think about, well, what would it be ticking if it was positive, and then tick the opposite too if it's negative. So next one, tan x is equal to positive 7/5, and we know tan is positive, A for all and T for tan. Cos x in this one is equal to positive 1/2, so all things positive and cos positive. Tan x in question 5 is equal to negative 1/2, so it's a negative. Now, if I was going to be looking for where tan is positive here and here at A and T, therefore negative at the other two, so I'm going to tick sine and cos. And if sine is equal to negative 3/4 to the last one, I know sine is positive at A and S, and therefore it must be negative at the other two, so I'm going to tick the tan and cos instead. Now we know how to use that cast diagram. We're going to put it into practice in solving a trig equation. This is what a trig equation will generally look like. So what you've got here is you've got solve, which basically means we're going to find the values of x, a number multiplying either sine x, cos x, or tan x, sometimes plus or minus a number and equal to another number. The bit at the other side here, that's just saying that we're only interested in this question in finding all of the solutions that are between 0 and 360 degrees, and that's all that really means. Now, the first thing we always have to do in a trig equation is we need to make either sine x, cos x, or tan x the subject of the formula. So at the moment, this sine x has the 2 multiplying it and then the 5 added onto it. We need to get rid of this 2 and this 5, so it just says sine x equals. Now we do that the same way we solve a normal equation. We'll start off by taking away 5 from both sides, and that will leave us with 2 sine x. Take away 5 from that side, and the other side leaves us with a 1 there. Next thing is I want to get rid of this multiplication by 2, so I'm going to divide both sides by 2, and I'm going to get sine x equals, and the 1 divided by 2 can be written as 1/2. And generally we'd probably want to leave it as a fraction like that. We wouldn't change it into a decimal or anything. So that's the first step, must be rearranged to sine x equals, so there we are, sine x equals. The next thing is to choose quadrants. Now that's the quadrant diagram we've just been practicing, so let's have a look. We're going to write it out. All scholars take care, and we are going to look at whether the sine x here is equal to a positive or negative fraction. Now that's positive 1/2, so I know that sine is positive here and here. All things positive in this quadrant, sine positive in this quadrant. The third step is to find the acute angle. Now, I'd usually do that bit of working up at the side of my cast diagram here. Now, because sine x is equal to a half, to find my acute angle, what I'm going to do is I'm going to find inverse sine, which is sine with 3 minus 1 of a half. Now, there's a little note we need to be really careful of here. Whatever goes in this bracket, okay, you must use a positive value here. So even if that had been sine of x equals negative a half up here, I would still need to put positive a half in this bracket. So when we're finding the acute angle, we always use a positive value in this bracket when we're doing inverse sine, inverse cos, or inverse tan. Now, inverse sine of a half, if you type into your calculator, you may need to press the shift or second function button before you press sine to get inverse sine. Inverse sine, open brackets, 1 divided by 2, close brackets, and we get 30 degrees for that. Now, the reason I do this bit of working up at the side here is because this answer here is just my acute angle. It may or may not be one of the solutions for x. In this case, it is going to be, but the number you get here won't always be one of your two answers, so that's why it's just up at the side, and then we'll go down and find the values of x. Now, the cast diagram, at the start, we split our big cast diagram into two parts. This part, which we've dealt with already, and the rules that go with that, and I'm going to kind of draw them down in the bottom right-hand corner here. So what you remember is we have A for our acute angle, which is now our 30 degrees, so this is the value of A is 30 degrees. If I have a solution in the second quadrant, the rule was 180 minus the acute angle. In this quadrant, it was 180 plus the acute angle, and in this quadrant, it was 360 minus the acute angle. So not only do I have to memorize this cast diagram, I must memorize these 4 rules that go in each quadrant. So if I look at the quadrants that I actually ticked in this question, I ticked the first quadrant A. So over here, that tells me one of my solutions is just the acute angle, which is 30. So I'm going to write that down. 30 degrees is one of my answers. Now I have 2 ticks here, so that means there are 2 solutions. So this quadrant here that I ticked with the S in it, the corresponding to rule to that is in this quadrant here, the same quadrant. So 180 minus the acute angle. Now remember, this is our acute angle, so the solution is 180 minus 30. Generally, I'll write that out as a calculation and then work out the answer underneath, which is fairly straightforward. That's going to come to 150 degrees. And those are my 2 solutions that lie between 0 and 360 for this trig equation. We'll try one more with a different trig ratio on the next slide. Now, in this one, we have 4 cos x plus 3 equals 2. And like we said before, it's this cos x part here. I need to get that completely on its own. So this one must be rearranged to cos x equals, so I need to get rid of the plus 3. I need to get rid of the multiplication by 4. So let's start off by taking away 3 from both sides. That would leave me with the 4 cos x here. If I take away 3, that will disappear. And taking away 3 from the other side will leave me with negative 1. I've then got to undo this multiplication by 4. So I'm going to divide both sides by 4, leaving me cos x equals negative 1 over 4. So that's the first step done. It's rearranged. Cos x equals, I now have this cos x equals here. The next step is to choose the quadrants. So if I choose the quadrants, I need to draw my cast diagram out. So all scholars take care. Now in this case, cos of x is equal to a negative fraction rather than a positive fraction. So we know that cos of x is positive here and here, so it must be therefore negative here and here. So we're going to tick the opposite 2 quadrants than what we would tick if it was cos x equals a positive fraction. Once we've done that, we're going to go on to the next step, which is to find our acute angle. Now our acute angle working, remember, goes up at the side of your cast diagram, and we must use a positive value. So if I've got cos x equals negative a quarter here, to find the acute angle, I'm going to have to use inverse cos. Now in that bracket, the thing I'm going to find inverse cos of, the important thing to remember is we must use a positive value to find our acute angle. So even though that says negative a quarter here, I'm going to use positive 1 quarter when I'm finding my acute angle. So inverse cos of a quarter is 75.5 degrees. And then what we're going to do is we are going to use then our quadrant diagram to find our solutions. Remember, the answer I've put up here is just me calculating the acute angle. It doesn't mean it's one of my 2 values of x. That's why, again, we do it up at the side. So the quadrant diagram, remember, you must know the corresponding rules that go with it. So acute angle, 180 minus the acute angle, 180 plus the acute angle, and 360 minus the acute angle. So if I look at this here, the two quadrants I have ticked are S and T, corresponding to this rule and this rule, so those will be my two solutions. So underneath we're going to write x equals, and we've got 180 minus my acute angle. Remember, this is where I've worked out my acute angle, so it's 180 minus 75.5. So I'm going to write that out. And the second quadrant here is this quadrant here, which corresponds to this rule, 180 plus the acute angle. Again, that's my acute angle, so 180 plus 75.5. And all I then need to do is work out those two calculations. So 180 minus 75.5 is going to give me 104.5 degrees. And lastly, the 180 plus 75.5 is going to give me 255.5. Now, what we have on this page is we have two questions for you to try yourself. So you can pause the video, try both questions, or try one question, then press play to go through it, and then try the next question and press play to go through that. It's up to you. So pause the video. Once you've done one or both, press play again to go through them. Okay, so let's start with the first one here. We've got 2 tan x plus 7 equals 8. So it must be rearranged to either this, or tan x equals, obviously this is tan, so it's this one here. So I'm going to start to take away 7 from both sides. So 2 tan x equals 1. I'm going to divide both sides by 2. So tan x equals 1 over 2. And then we're on to find our quadrant. So we're going to draw our quadrant diagram out. I'm going to try and leave myself a bit of space here. So all scholars take care, and then we're going to look at the tan x is equal to a positive fraction. So where is tan x positive? Well, tan is positive. A for all things are positive here, and T for tan is positive. So we're going to tick the A and the T, and then we're going to go back and we're going to now find the acute angle. Now remember, we always use a positive value when we're doing this. It just happens that this is actually positive anyway, so that's not going to be too much of an issue. We're going to find inverse tan this time, because it's tan, of a half. And remember, whatever goes in that bracket there must be a positive value. Now inverse tan of a half is 26.6 degrees there. And what we're going to do then is we are going to use our quadrant diagram. I'm just going to sketch this out at the side. Remember, our rules are acute angle, 180 minus acute, 180 plus acute, and 360 minus acute. So if I look at which quadrants I've got solutions in, I've got a solution here. So that's the first quadrant. So that's just the acute angle, 26.6. So x equals 26.6. Or, and my other solution is in this quadrant, which has the rule 180 plus the acute angle. So 180 plus my acute angle here. I'm going to write out that calculation, 180 plus 26.6. And to quickly do that, that's going to be 206.6. And that is my two solutions for this trig equation. The next one is 6 cos x plus 3 equals 2. So again, we want to first of all rearrange it to sin x, cos x, or tan x. Obviously this is cos x, so it's this middle one here. I'm going to take away 3 from both sides first. So 6 cos x equals negative 1. And we're going to divide both sides by 6 next to give us negative 1 over 6. Step 2 here is to choose our quadrant. So that's where we're going to use our quadrant or cast diagram. All scholars take care. And we are going to then have a look at what we've got here. Now cos of x is equal to a negative fraction, so we've got to say, well, where's cos negative? The easiest way to do that is say, well, where is it positive first? Cos is positive here, and therefore it must be negative in the other two, here and here. So we're now going to go on to the next step, which is to find our acute angle. And remember, the important thing here is we must use a positive value. So even though this is negative 1/6 here, when I do inverse cos of that fraction, I need to make sure that I use positive 1/6 in my calculation. Okay, so we're going to type that into our calculator. Remember, that is your shift or second function button, then cos, to get your inverse cos, and that comes to 80.4 degrees. Now, what we've got then is to work out what our actual solutions are going to be, and that's based on our rules down here, matching up with our cast diagram here. Now the quadrants we have solutions in are this one and this one, which correspond to these two rules. So 180 minus my acute angle for this one, so 180 minus 80.4, let's write that out. Or in the other quadrant here that's ticked, this tan quadrant, that corresponds to this one, is 180 plus the acute angle. So again, we're going to write that calculation out, 180 plus our acute angle of 80.4. Now, from there, all we need to do now is do those two calculations. So 180 minus 80.4 is going to be 99.6. And 180 plus 80.4 is going to be 260.4. And that's how we solve basic trig equations.